Good morning, everyone. I'm the last one, so really appreciate your attention in my presentation. Today I'm gonna talk to you about my lesson plan of how, in the purpose of how I teach my experimental lesson to investigate the principle of concurrent force superposition. So in my lesson, I really want and hope and also expect my student can not only can gain about the knowledge of the principle, but also they can design the experiment to investigate the principle by themselves. In addition, they can manipulate all the apparatus to set off and execute the experiment in the most effective way. So, to obtain all of this expectation, so what can I do? The first thing I want to have my student, the first thing I will remind them some background knowledge about the concept of force, which can actually force just an interaction between two bodies or between bodies with this environment. The second concept is the effect of a force must be the acceleration and deformation. Furthermore, such an abstract quantity like a force can be represented by a vector, which can show not only the magnitude of the force but also its direction. Our students also familiar with the concept of the resultant force. The resultant force, if a resultant force acting on an object, so it has the same and identically effect with its component forces. And the last thing I want to remind them is a apparatus to measure the force, so they must too familiar with the apparatus called dynamometer. So moving on to the next matter of my strategy to teach our student about the principle of concurrent force superposition, I must go straight ahead with the phase number 1 called Exlist the problem. To engage, or I must say to provoke our student to get involved in, they really want to investigate this principle. I will set them in a specific situation like this. I have an elastic spring here, which has one end is fixed on the surface like this, and the other end of the spring I will connect it with the Y-shaped string like this, and I will pull. If I pull all of two ends of this string, actually I'm just acting two forces, F1 and F2, on these two ends. So the effect that I have just mentioned before, that effect on this spring, it will be deformed, right? So anyway, the next step, I will change one factor of these forces. Let me see, just one factor. For example, you just change the magnitude or its direction. It depends on you. So this spring here will be deformed differently. Okay. So as I mentioned for them before, that the resultant force has the same effect with its component forces. So is there any relationship between the resultant force and this component forces here? So there must be some relationship here. So my student can maybe they can curious about this stuff. Continuing with the second phase, which is the problem solving with this experiment, I will direct them to solving this situation in an experimental approaching way. So, to do an experiment, the first thing I want my student they have to know about the purpose of this experiment is to verify the principle. I know that, but we have to make it more clearly. The first content that needs to be investigated is we need to investigate how the direction of the resultant force depends on the direction of two concurrent forces. And the second content is we have to find a mathematical formula that represents the relationship between resultant force and its component forces. Okay, that is the content that we need to do, that we need to investigate them. So continuing to the next step, I will guide them by giving them some engaging question, and let them can design an experiment by themselves based on this situation, based on the situation that I have mentioned at the beginning of the lesson. So I will ask them about the how can we determine the magnitude and also the direction of these boxes. Let me see. This experiment is to investigating the relationship between F1, F2 is the component forces, and F is the resultant force. So to investigate this relationship, we just easily do like measure this one, measure this one, measure this one, and based on its direction as well to find out the relationship. That is the key, that's the point idea here. So my student can easily catch the idea of that we can measure magnitude of this one and this one by dynamometer, but also when we after we add two component forces here, we have to mark the position that the spring here be deformed because this one is fixed. Okay, so I will mark the position here.
No, better to do the experiment and then the same time.
Okay.
So
okay.
how to divide the result in four and how to determine the relations. Same time.
Okay. In the process I do this experiment, also I can give them some notification so that they can have the most effective result. Here I have an elastic spring here. I fix that. Okay, I fix that with this position, and I connect this Y-shaped branch string here with two forces here, like this. Here. Okay, so we can see that this one will be deformed. Okay, so I will mark the position that is be deformed in this way, in this position, like this. Okay. Okay. So I will release all of this stuff. Like that. And to replace what?
What is F1 and F2?
You forgot. To raise the manager and also market.
Sorry.
Yes, apologize, not satisfied.
Okay. This one here, this two here. Okay. I mark them, and I will read the indication. Actually, it is magnitude on this dynamometer. This one is approximately 1.5 newtons, and this one also is 1.5 newtons. So
it's not full.
okay, I will make it differently. Okay.
You should prepare all of this task with how big is that? You must prepare before.
Okay.
Not here and spontan, randomly F1 and F2 choose is not good.
Okay.
Okay, that's so far. Let's do what you prepare. Yes. Let's do
One
what you
position
prepare.
here. Okay. Okay. This one read the value of 1 newton, and this one is 2 newtons. So I will make a ratio. If it is 1 newton, so I estimate this kind of 3 centimeter like this. And this one is 2 newtons, so I estimate it like, what is it? What is it?
Do it quick. 1 minute.
Okay, this one must be about 6 centimeter. This. And then I will replace all of these forces just by one forces that this spring will be deformed identically before. And the value is written here is about 2.2 centimeter, so it must be more than 6 centimeter. Kind of 6.6 centimeter.
Small.
You can use double length, 3 times the length.
What did you mean?
Demonstration, hey. But okay, no time for that next time.
Okay, so I will connect this top of this vector
Also.
to the top of this vector like this. So we can estimate like these two direction of these forces can make like a parallelogram, and we do this experiment for several times to conclude about the relationship between them.
How you can prove that figures on the board is parallelogram?
Based on its length and its angle as well.
How? Show me some evidence.
Okay, so this one is 3, this one is 6, and also actually I need a ruler that can measure this angular. That's by somehow in mathematical way you can find this.
And then you measure the angle, and then how to prove that is diagonal.
Yeah, we use this equation right here. Yeah.
You want to calculate something? You want to calculate the diagonals?
You didn't think about this before?
Yes, I have thought about it before.
So
Was
why
it
did
just
you
calculated?
prepare the tool to measure the angle? Did you say you prepared before?
Sorry, I can't find
Is it
that.
alright?
No, because
But where's the tool to measure angle? Show me.
I just don't know where to find them. I find over the room, so.
Is there any other method to prove that the teacher is parallel
Parallelogram.
Yeah.
The single way.
Yeah.
Just use a ruler. How?
Use the ruler.
The ruler try to prove the figures we can see is parallelogram. Just use the ruler. Otherwise, I am in doubt of your math knowledge.
Sorry. To demonstrate this is parallel.
Oh, okay. In this case, my name is Manson. No. Okay.
Sorry, your time for me.
Okay.
Enough.
Is this enough?
Thank you for your attention.
Okay, thank you guys. At least you try and we'll see.